Okay. Hey everyone, welcome to hok'stutoring. Hope you're having a great day. Today we are doing question 13 from chapter 13b. So this is your lift type scenario question where you have an object inside a lift and the lift is either going up, down, or is stationary, meaning it's at rest. Okay, so question 13 is a little bit confusing style of question in general. So let's have a go. Hopefully this video helps you solve this question. But question 13, let's try. So hopefully this video helps you solve this question, but aside from that, let's get into it. Question 13. In a lift that is accelerating downwards at 1 meters per second square, so with these type of questions, I always recommend you draw the diagram. We have a lift here. I've already drawn some parts of it for you, and it's accelerating downwards, so it's going down at 1 meter per second square. Okay, that's what we know. And a spring balance shows the apparent weight of an object to be 2.5 kilograms weight. Now, what that spring balance mean, or what that apparent weight of the spring balance mean, is the normal force. So that's another way of saying the reaction or the normal force. Okay, so that's what it is. It's your reaction force, it's your normal force. So your reaction force in this case, I'll label it as R, is 2.5 kilograms weight as it's going down. Okay, so 2.5. Now make sure the unit is proper, okay? If you want to use everything as Newton, then you need to make sure you multiply it by G, because 1 kilograms weight is equals to G Newton. So if you have 2.5 kilograms weight, you have 2.5 G Newton. So that's the apparent weight. It's telling you your reaction force. Now the question is, what would be the reading of the lift, or what would be the reading so if the lift were at rest? So if the lift was at rest instead, what would be your apparent weight? Okay, that's what it's asking. And then also part B, when it's going upwards instead at 2 meters per second square. So first of all, let's label everything in our diagram. You have your reaction force, and obviously you have your weight force. Weight force is always equals to mass times your gravity, regardless of any scenario. Okay, now if you want to find the reading, the normal force, when the object or when the lift is stationary, so if the lift is stationary and it's asking you for your reaction force, the apparent weight, then, and of course acceleration is 0, then what that means is your reaction force is just equals to your weight force, which means reaction force, the apparent weight, is equals to mass times gravity. We know gravity is 9.8 on Earth, but the only constant that we don't know here is our mass. So technically, if we know our mass, we can find the answer to part A, because that's just the mass times gravity. So how would you find mass? The way to find mass is using the scenario they gave us at the start, okay? So when the lift was going down. How would you do that? We know the lift is going down, so that means the downward force, the weight force right here, is bigger than your reaction force by that proportion, okay? The acceleration equals to 1. So let's have a go. We have net force equals to m times acceleration. Our net force here would be mg, your weight force, minus your apparent weight, which is 2.5 g, and that would be equals to your mass times acceleration, which is just mass times by 1. Now, assume going down is positive. We always want, whenever you're using the Newton's second law formula, always assume or always try to make acceleration positive, okay? So going down would be positive in this case. So let's try to solve for mass, because if we solve for mass, we can answer our question to part A and then also for part B. So mg, we move the m over to the left side and we move the 2.5g over to the other side, and then just factorize it. We get m multiplied by g minus 1 equals to 2.5g. Guys, you're just solving for mass. That is 2.5g divided by g minus 1. Put inside your calculator and your answer should be 2.78 kilograms. Okay, so once you know your mass is 2.78 kilograms, that's the mass of this object right here, then if you want to find the apparent weight of that object at rest, so you know what the spring balance or what your weighing machine tells you, is very simple. Reaction force equals to mass, which is 2.78 multiplied by g, which is 9.8. And if you chuck it inside your calculator, guys, you should get actually it's very simple. If you want to put in Newton, it's 2.78 Newton, or if you want to leave it in kilograms weight, which I think the book does, then put it as 2.78 kilograms weight. And that's pretty much it, guys, to solve part A. So the weighing machine is going to tell you, or the spring balance in this case, is going to tell you that your weight is 2.78, okay? Right, now, part B, what would be the reading if the lift were accelerating upwards at 2 meters per second squared? Okay, so I'm going to move over to the right. I'm going to draw another lift over here, but this time your lift, the object or basically the entire lift is going up at a rate of 2 meters per second squared. Okay, so once again, we have our weight force, as always, m times g. We know m is 2.78. Mass does not change, it's constant, okay? 2.78 multiplied by g. And of course, we have our reaction force. This time, we don't know because if you're going up, your reaction force changes, okay? Now, because your lift is going up, that means when you apply your Newton's second law formula, then it's reaction force minus weight force instead, because reaction force is bigger than your weight force. So we go reaction force minus our weight force, which is 2.78 multiplied by g. That is equals to mass, once again, 2.78. And our acceleration is going upwards. We always try to take positive acceleration as positive, so that it balances out. So you get a positive answer basically. And what you get for r is 2.78 multiplied by 2 plus 2.78 multiplied by g. Chuck inside your calculator, guys, and what you should get is 32.85, but that is in Newton because I used the G, so that means everything's in Newton. If you want to convert it back to kilograms weight, just divide it by G, divided by 9.8, and your answer should be 3.35 kilograms weight. So that's pretty much it on how you want to solve this question, guys. Question 13, chapter 13b. So hopefully you found this video useful, and if you did, please leave a like. That would help support this channel a lot. And aside from that, guys, thanks for watching, and I'll see you in the next video.